We are doing 3.6 compound inequalities. Okay, so we're going to solve and graph them. We're going to solve and graph inequalities with an and, solve and graph with an or. I would also add to that, which they didn't say in their little objective, is we're going to learn about interval notation. Okay. So, all real numbers, don't write those words out. Remember, you can make that double stick R thing to represent all real numbers. Okay, so all reals, you can write that. Greater than -2, less than 6. Okay, so that's what you got to write. And then over here, all reals, you can use the double stick R again. Less than, or is the key word, right? And is the key word here. Greater than or equal to 5, less than 0, or greater than or equal to 5. So we're going to write inequalities with an and an or. Okay? So this first one is our and inequality. When you write these things, especially with an and inequality, but any of the inequalities as well, you always want to have small number on the left, big number on the right. But first, we're going to write this as two separate inequalities. And inequalities you'll normally write together as a single inequality, but I'm going to walk you through the process here to show you how it works. So we have all real numbers. That's what our x is going to be, greater than -2 and less than 6. So x is but when you have these and inequalities, you have to write them together. When we do write them together, you put the small number on the left. The inequality signs are always less thans. So remember, if you have any bit of dyslexia and you get confused less and greater, I know I did when I was in school, left hand less than, it makes a less than sign. So it's always less than. Big number on the right, variable in the middle. I don't need the lines under because it never said greater than or equal to here or less than or equal to. So that's why it's just less than signs. Okay? So you're done right here. So just to review, we want the small number always on the left side, big number on the right side. Small number, left side. So I want these to become like automatic to you. You see two numbers, bam, small number on the left, big number on the right. You see and, less than. The only thing you really have to look at is if it's equal to or not, and then you're good. So that's the one on the left there. We'll go to the one on the right. So all real numbers. Now this is an or inequalities you always write as two separate inequalities. So we have x is less than 0. And then when you have an or inequality, write the or. On the one below on the left, the and is implied because you write it as a single inequality. So x is less than 0 or x is greater than or equal to 5, like that. So and write together or write separate. Even though, like, if you were to write this on a test or a quiz or something, I would still take points off, even though you technically have it correct. You didn't write it together. That's why I would take the points off. So that's the first one. Second one, so write the all real numbers like we talked about. Greater than or equal to -4, less than 6. Is this top one an and or an or? Somebody unmute and tell me and or.
And?
Yeah. Okay, right? It says and right there. That's how you know. So we go -4, small number on the left, big number on the right, x in the middle. I know it's going to be less than. I just don't know yet if it's equal to. So greater than or equal to -4 and less than 6. So we're good there. So the weird part about these and inequalities is you read this one, x is greater than or equal to -4. So you read it right to left instead of, or sorry, I should have said right to left instead of left to right. Like this one, you read normal, left to right. This one, you read right to left, okay? But as long as you remember small number on the left, big number on the right, they're always less than. You don't know if it's equal to or not until you read it. Variable in the middle, you're good.
Wait, did you just say that there always be less than?
Always less than in an and.
Okay.
Every time. Okay, so this one's an or. Says it right here. So all reals that are less than or equal to 2.5. So x is less than or equal to 2.5. You could write 2.5 as well. I don't really care. That'd be fine. Thank you for those of you that have your camera on. And then we're going or greater than 6. So x is greater than 6. Less than or equal to 2.5 or greater than 6. So let's talk about graphing these things. Now we'll talk on the next, I think it's the next one we'll talk about graphing. Yeah. All right, so let's write this one. This is the first one where we actually have to do some math to solve it. So write that down. And then the only difference between this and a regular, first of all, is this one and or? You can tell by looking. It's an and, yeah. Right? Because you have small number on the left, big number on the right, less than, variable in the middle. Doesn't matter that there's this other crap in there. It's still good. So you may remember sometimes I draw a line down the equal sign. It's technically like we have two equal signs now. They're just inequalities. So I want to get the variable by itself, cover up the variable. How do I get rid of that -4? Simply add 4. But the difference this time is that I add 4 to the left, middle, and right. When you have an and inequality, whenever you do an operation, you need to do it to left, middle, and right. All 3 parts. So on this side, I always like thinking of this like 4 minus 3 instead of -3 plus 4. Easier for my brain to think of 4 minus 3, which is 1. M in the middle, less than on the right. 4 minus 1 is 3. And now we're going to graph this thing. I'll let you get caught up. So when you make a graph, when you have an and inequality, the arrows connect. When you have an or inequality, the arrows go out. So small number on the left, big number on the right. It works for when you're writing the inequality and also when you're graphing. Always small number on the left, big number on the right. Open or close dot at 1. Show me with your hand. Open or close dot. Close, good. Close dot at 1. Open dot at 3. And the arrows connect. I'm going to shoot, let's just do that. So I want to show you this graph in a just slightly different way. Let's talk about this answer first, though. So I think of these and inequalities like it's in between 1 and 3. Somebody tell me, show me with your fingers a number in between 1 and 3. Ari was ready already. 2, right? So is 2 greater than or equal to 1? Yes. Is 2 less than 3? Yes. Okay? So if I show you this graph, because you might see this at some point, some people will graph it like this too. So we just showed the 1 greater than graphed. I'm going to graph it above that line and show the 3 less than. And then the solution set is only where these things overlap, including this closed stop. Okay? So you could graph it like this. I tend to be a little lazy and I want to graph like this. They just connect. It makes it easier. Or you could graph both and just shade in the middle where they overlap. So if I plug in something like 0, 0 is not greater than 1. That's why that does not work. 0 is less than 3. So it works for this side, but not for this side. And inequalities have to work for both equations. I'm going to write that down and I'll take your question in a second. And inequalities they work for both equations. You could say, and inequality solutions work for both equations. And then when you have or inequalities, solutions work for one or the other equation. So just one equation, that's all it has to work for. All right, Ari, question?
That's fine.
All right, cool.
Thank you.
Yep. So get that down. These little things will help you. You'll do the homework. I'll teach it, you'll understand it, and then you go to do the homework and you're like, what the hell happened? I thought I got it, right? I know there are people in here who have had that experience. So these little things will help kind of ground you and remind you of what's going on. Also watch a video, like when we talk about set or interval notation, if you're super confused by that the first time we talk about it, you can go back and scroll through the video and just watch that example solely. Take you like 5 minutes and then you understand. So I encourage you to use the videos in that manner. You'll understand better. I'm going to give you 2 minutes to solve this equation. Solve and graph. So 2 minutes. Have at it. Oh, the other update with the whole Google Meet thing, so you guys know, it sends me an email after every class of who was in attendance and how long you were in attendance. Okay? Just so you know. So those of you that have played the little weasel game about like pretending like you're in class, you're just hurting yourself, right? So just be in class if you're in class. Got about a minute left. Solve and graph. the bell. Okay, so we're doing all three parts. First thing we're going to do is add 4. Left, middle, and right. 4 minus 2 is 2. Less than 3y. Less than 18. Then just divide by 3. Left, middle, and right. And we get 2/3 less than y less than 6. Graphed. 2/3 on the right, 6 on the 2/3 on the left is what I meant to say. 6 on the right. Open dots on each. Arrows connect. So always when you see it written like this, the arrows will connect. Now, that's in Algebra 1. It always happens that way. Know that you can have and inequalities that go the same way, or inequalities that go the same way.
Can you go up?
It's totally possible for any of those scenarios. Is that good, Anna? Yes, I'll take that as a yes. Okay, any questions on this? Cool. So we just did 2 steps. This problem, I guarantee you will see something like it again. So that means I'm going to spend another day on this topic because I kind of threw this one in tomorrow. So you have a lesson quiz tomorrow, and you will have a problem like this on your lesson quiz. So focus. The and inequality, or let's just read it first. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86. So what's your test average have to be?
'84 and '86.
What number's in between 84 and 86?
85.
Aha, yeah. So you want an 85 average, right? So that's in between 84 and 86. So when it says between 84 and 86 inclusive, that word inclusive means and inequality. So they love to use that word inclusive, and you always write it as an and inequality. So you scored 86, 85, and 80 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to get a B? So small number on the left, big number on the right. So they want it between 84 and 86. So I'm going to write the 84 here and the 86. I'm leaving intentionally a big fat gap in between here. I know that they're going to be lessons because they're always lessons when you write an and inequality. I know I'm going to have some kind of variable in the middle, but what's different about this problem is I have 1, 2, 3 numbers in the middle, and then I have the 4th test. So what do I need to do to represent the 4th test?
+4 in there.
Our math gang sign, we need an X in there as well, right? So we're going to have 86 plus 85 plus 80, right? Those came from right here. And then I have to add the X. Now it said I want an average of a B. How do I get an average of 4 things?
Add them and then divide.
By however many things you have, which in this case is 4. So that's the setup, okay? So inclusive tells you it's an and. It gives you the 2 numbers on either side, 84 and 86. So you put them on the ends of your inequality. You also have less than's because they said between. That's why it's less than and not less than or equal to, because 85 is the only number in between. And then you have to add your 4 things up and divide by 4 to get an average. And now we can solve for X. So what's in the way in solving for X? This divide by 4 is in the way. So the opposite of divide by 4 we are going to multiply all three parts by 4. Left, middle, and center. In the middle, the reason we're doing it is because the 4's cancel. 84 times 4, 80 times 4 is 320. 4 times 4 is 16. So 336 less than, if I add 85, 86, and 80, 80 times 3 is 240 plus 11, 251 plus x less than 86 times 4, 80 times 4 is 320, 6 times 4 is 24, 320 and 24 is 344. Okay, just modeling that mental math, because when you take SAT, the single most important test of your life, part of it is no calculator. So if you're super used to using your calculator and all of a sudden you can't use one, you'll do worse on SAT, won't be able to get in as good a college as a result. So pay attention when I do the mental math stuff, because you'll need it. Okay, so all I have to do now is subtract 251 from all three parts. Right, so if I'm drawing the lines down the inequalities, that's the way it goes. Right, so make sure you do it to all three parts. Now I can subtract this in my head and think it's 85. What drives me crazy on your quizzes and tests is when you subtract this and you subtract it wrong and then you don't realize. So I think it's 85. I'm going to go ahead and double check. 336 minus 251 is indeed 85. And then double check on the other side. 344 minus 251 is 93. So think in your head what it is and double check in the calculator, because you're more likely to do better if you do it that way. So we have 85 here. We have x in the middle. We still have our less than signs in 93. So I could give you this problem and say, explain if you think it's likely or not. Like, is this kid going to get, let's say his name's Sam. Is Sam going to get the 85 in the class? What's the likelihood? Somebody try to explain, and then we'll kind of work on the explanation. So what's the likelihood, given his score so far, that he's going to end up with an 85 in the class? Somebody see if they can explain that concept. Oh, we get awkward moment. I love this. That's when they sit down, get to stare at your smiling and comfortable faces. How likely is it that this kid's going to end with an 85 average? I'm going to call on somebody random here. And guess who I will always call on? Somebody without their camera on. Aw, isn't that nice? Dominic! Now we can see if Dominic's still here.
I would say high, like a high chance, because he's only gotten one score or two scores that's below 85.
And how many has he gotten above?
And 3. So.
Wait a minute.
And also.
That was flawed right there. Who can help? So Dominic thinks it's a high chance. I disagree. Why do I disagree? Go for it, Jay.
Well, he's gotten like lower scores, so it's possible that he'll get a score lower than 85, just because of the chances, just because of his other
test scores,
answers that he's gotten. Yeah.
Yeah, for sure. Right? So he needs an 85 average. He hit it exactly. He's got one solidly below, 5 points below, and only 1 point above. So his average right now, if you're to average 86, 85, and 80, let's just see what that is. 86 plus 85 plus 80 divided by 3. Like his average is almost an 84, so it's a little lower. So what would he have to do to get the 85? Probably just study harder, right? Make some flashcards. I emphasize flashcards all the time. If I had you in person, I would force you to make flashcards. Hopefully that'll happen soon, but not yet. So I think because he has one score exactly and one score quite a bit below, it's less likely he's going to end up with that 85 average. But it's still possible for sure, right? If the first 3 tests he had like a 72 average, I'll have kids actually email me with a 72 average right before the final in Algebra 1 and say, well, how do I get a B? And I say, you can't. It's not going to happen. You have a 72 in the class. One test is not going to raise your grade up that much. So I'm always honest about that kind of stuff. Okay, we're not going to do that one. So OR inequality, write this one down. When you do an OR inequality, you just do 2 separate problems, okay? Because people get all confused on this kind of problem. We're just going to do 2 separate problems. Okay, we'll do 2 separate problems, but we are going to graph on the same number line. So historically, what I've seen out of Algebra 1 students, I'll put a problem like this on a quiz. They do one of the 2 problems and just kind of ignore this other one. And I'm like, what the heck? Do them both. You see 2 problems, always do them both, right? So I'm going to write this one below. First one, we have 3t plus 2 less than -7. That's a 4. Less than -7, or -4t plus 5 is less than 1. I intentionally write that or as a reminder, right? Because and inequalities in Algebra 1 are going to join together, or inequalities are going to go out. That's why I write the or, just to remind me. Because I don't know if any of you have made stupid mistakes when you've done a math test before, but hell yeah, you have, right? So write the or so you remember what to do, right? Now we're just going to solve these 2 separate problems. On the left one, I'm going to subtract 2 from both sides. On the right one, I'm going to subtract 5 from both sides. I end up with 3t less than. Remember, when you're subtracting 2 negatives, add the numbers, keep the sign. 7 plus 2 is 9, keep the sign, -9. On this side, we have 4t is less than -4. Left side, divide by 3 on both sides. So t is less than -3. On this side, we're dividing by -4 on both sides. When you divide by a negative, what do you have to do to the inequality? Flip the inequality. Okay, so flip. So we end up with t is greater than +1. Just like when you multiply 2 negatives, you have a positive. When you divide 2 negatives, you have a positive. So those rules work with multiplication and division. Now we got to graph this thing. Again, I'm going to write that big fat or. I'm ready to graph. I want to remind myself it's an or, so I remember that the arrows go out. We're going to graph it, as I said above, on the same number line. We're going to go -3 on the left, small number on the left, always. Big number on the right, always. Open or close stop, show me. Open, excellent. Open or close stop, show me. Open, 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 good. So open dots on both. I see or. I don't even really have to think about it. Just make the arrows go out. So if you like that kind of thing, don't think about it. Just know how it works. That works for you. If you do like to think about it, you can plug in numbers to double check that you did it correctly. Like if I plug in -4, that's less than -3. I graph the correct direction. You could also think about that hint I gave you before, where the inequality and arrow point the same way. Plug in a 2. 2 is greater than 1, so I graph the correct way over here. And that's the graph. Good. Looks like everyone's done writing that I can tell. Moving on. I'm not going to do that one. Okay, so we're going to talk about this interval notation because this takes a while just because you haven't ever seen it before. So I'm just going to copy this over. Write this down. Real quick, leave yourself some room on the right side here because we're going to do the interval notation on the right side. So just sketch these graphs real quick. Don't number them all. Just write the -3 and 4 and the arrows going whichever way they go. You know, you don't have to be crazy about it, but get this down because the interval notation will make way more sense if you do. So those of you that came in, I don't know if everybody heard this, but if you want to know, I was seeing if anybody was using it. Yeah, Ari's got it on. So if you click where you would hang up in your Google Meet, like click at the bottom, and if you click the 3 dots at the bottom, it's all laggy right now. Click the 3 dots on the bottom. Then you'll see where it says turn on background blur. Why doesn't everybody try that right now? Turn on background blur. Austin and Ari have it on right now. So you can see
Mine doesn't have that.
Yours doesn't? How about anybody else? Turn it on if you can. I'm just curious. Cole's got it on. Christian's got it on. So, you know, I had this one kid last spring who had like 3 toddlers in her house. Like it was clear her mom was working and she was taking care of the toddlers. And it was just like super distracting. So that student could have blurred her background and it just makes it easier. You don't have to deal with everybody seeing your situation. If you don't care, you don't care. I personally wouldn't care, but just to protect people's privacy if they want to. Okay. Interval notation. Okay, we're going to make some rules to talk about interval notation kind of as we go through these. But we're starting with a graph. X is greater than or equal to 2. So if you have a closed dot, we're going to use brackets or parentheses with this interval notation. So we're going to use closed dot is always, so I'm just saying equals a bracket. And I'll tell you about which way the bracket faces in a minute. So bracket is in it's squared off, not curved. So closed dot is a bracket, open dot is always a parenthesis. So curved versus squared off. And when we talk about infinity, so open dot, or when you talk about either negative or positive infinity, it will always be parenthesis as well. That was a terrible arrow. Let's try that again. Okay, so closed dot bracket, open dot parenthesis, infinity parenthesis. It won't make any sense yet, so just bear with me. I always want you to have faith in me as a teacher that I'm going to explain it so you're going to get it. Okay? So it's going to work out. So closed dot, do we have bracket or parenthesis?
Bracket.
Bracket. So it starts with a bracket. Okay? And then you write the 2 because that's what the closed dot's over. And then we go comma. So this includes every single number all the way to positive infinity. And positive infinity always has a parenthesis. That infinity was not beautiful. Mildly better. Okay, so let's do this one. It's an open dot, so we know we need a parenthesis. But over here, we're starting at negative infinity, and then we go to 2. So you always go small number on the left. 2 is smaller than infinity. We're going to do the same thing on this one. So infinity always starts with a parenthesis. This is negative infinity, comma 2. Because it's an open dot, that's why it has that curved parenthesis. We'll do a ton of these, okay? So if you don't get it yet, you will. So this was just graphing 1. X is greater than or equal to 2. X is less than or just less than 2. Now this is an and inequality. So when you see and inequalities in these brackets, you will always have 2 numbers. If you have just one inequality, you're always going to have either positive or negative infinity. So here, we're going to write the 1, comma 5, because those are the 2 numbers I'm talking about. Right? And then bracket or parenthesis. Open dot, parenthesis, closed dot, bracket. So when it's an and inequality, you're always going to have numbers here. You will not have an infinity, always numbers. So this one, we have 2 separate graphs. We need to write 2 separate interval notations like these 2. So it'll look like that just with these 2 different numbers, -3 and 4. I'm going to copy this to the next screen just because it's going to make it easier to write. So over here, we have negative infinity. Over here, we have positive infinity. This one goes to -3. This one goes to 4. So I'm already building my interval notation, right? Just by doing it like that. I know that infinity is always a parenthesis.
Mr. Evans, I think you're lagging out.
All right, is it caught up? Oh, that was a good look. I just saw my crazy look on my face. How's it now? You guys all look frozen. I'm going to hang up and come back in hopes that that'll help. Actually, I don't want to do that because I'm recording, but you're all frozen. Wow, I should take a screenshot of this picture with all your expressions. Oh, that's why. All right, hopefully that'll be better. Let's just give it a sec. Is it better, Jackson? Better? Can you hear me? Woohoo! All right, cool. Good deal. Hold on, let me see. I gotta fix my little tile view. I can see all you. Okay, there we go. We're back. So I'm building the interval notation, right? I have negative infinity over here. This one goes to positive infinity here. So I'm building it up, right? I always know I have curved parentheses here at infinity. And then open dot, parenthesis, close dot, bracket. Just put a comma in between and you're done. So I'm going to do a bunch of these. We're going to do like a less than, greater than with one number. We're going to do and or with the two different equations. We're going to go from graph to interval notation and the other way, interval notation to graph. Let me just see what my next slide was. This one, okay, good. Okay, so let's say we have x is less than or equal to -8. I personally think it's easier to see the graph and develop the interval notation from the graph. Once you get used to it, you won't need to do that. But I'm just going to graph this real quick, close dot. It's less than, so the arrow goes to the left. Arrow and inequality face the same way as long as the variable is on the left. Okay, so this over here is negative infinity. All you got to do is put the comma, always parenthesis at infinity, bracket at -8. Okay, next one I'm going to have you answer in the chat. So look at your keyboard to see where a bracket is and where you should know where a parenthesis is. You may not know where a bracket is. I'll leave that one up there for reference. I'll even give you the graph. So write the interval notation and put it in the chat, please. Oh yeah, I like Ari, the 00 for infinity works. I don't think you have an infinity symbol on your keyboard. That does make it a little, or you could write infinity or INF or something like that. And now, of course, you can all see what's in the chat and just copy it and write it. I know the game. So over here, positive infinity, comma, bracket, close dot, infinity, open dot, or parenthesis, I mean. Okay, give me fist to 5 on your understanding of this interval notation so far. 5, I totally get it. Fist, I have no idea what the hell you're talking about. Okay. Kason, good. I can tell exactly what you're talking about. Okay. Now we're going to do one with 2 graphs. So we have 0 and 3. I'm going to go close dot on 0, open dot on 3. My arrows are going to connect. So write the interval notation. Do you want me to do this one, or do you want to try it on your own? Santiago's back. So when it's 2 numbers, you just make 2 numbers. 0, 3, bracket, because it's closed dot, parenthesis, open dot. So I think the and ones are easy because you see the numbers that go in the bracket or parenthesis right away. To me, that makes it easier. It's good. A lot of people did the correct response there. Last, we'll do Same thing, 0 and 3, except the arrows are going to go out. So with this one, you got to write two different sets of parentheses, right? So negative infinity over here, comma, always parenthesis at infinity, close dot, bracket. You have to write the word or, open dot, parenthesis, and then positive infinity, like that. So next slide, we're going to have you go the opposite direction, which is weird. So we're going to write this one. So write it as an inequality. I think it's easier if you graph it first. So if we graph that, it's -4 and 6. Is this going to be an and or an or? Answer in the chat. And or or. When you see two numbers, it's always an and. Okay, two numbers, always an and. If you see an infinity, that's when you're going to do it different. So open or close dot at -4. Show me with your hand. Open or close dot. Close. 6 is open. It's an and. So they connect. Simple as that. Okay. I think that's an or one. I just want to see how many more we got. Okay. We're going to do last slide we're going to do here. So we're going to graph it. We're starting with x is less than or equal to -1 or x is greater than 2. So we're going to graph it and then write interval notation. So I have -1 and 2. -1 has closed dot. 2 has open dot. It's an or, so the arrows point to the outside. And then to develop the interval notation over here, negative infinity, parenthesis on the left, bracket on the right. Remember, you have to write the or. And then on this side, we have positive infinity, parenthesis, open dot on the 2, parenthesis at the 2.
So if there's a closed dot, it's a bracket on the number.
Yes,
But if it's an open dot, then it's parentheses.
exactly.
And no matter what, like if the dot's open or closed, there'll be a parentheses on the infinity.
Yes.
All right.
Perfect. Okay. Your homework is page 204. Nine through 37 odd plus 42. So make sure you study that problem that has the different test scores, because you will see a problem like that on tomorrow's quiz. All right, that's all I got. You can start to work on the homework and ask me as many questions as you need.